Welcome to a multi-part coding challenge series on kinematics. This is an example from Processing. Processing, a Java-based platform, open source, creative coding environment that I use in a lot of my videos. This is an example by Keith Peters from Coding Math, of the Coding Math YouTube channel, which I also highly recommend. I believe that Keith Peters has a set of video tutorials on this exact same topic. And if you're looking for the video tutorial where it's somebody who really understands the math and doesn't make any mistakes, I would recommend that video to that channel. So just go leave and watch that channel. But you can see this is an example called Reach 3. And what you can see is that there's this bouncing ball moving along, and that there's this kind of tentacle thing that's just reaching out, trying to touch it, trying to catch it, and then move along with it. And it behaves in this very, I might say, robot arm-like fashion. So this is an implementation of something called inverse kinematics, which refers to the motion of connected segments from the front to the back. So the front is what's really controlling it. It's trying to reach, and how should all these other segments be oriented so that that front can get as close as possible to this target. Versus forward kinematics, which is like, I'm going to move this. How should the rest of my arm move when I move this part of my arm, which is different than, well, I want to inverse, which I need to move my hand. How does the rest of my arm move in order to get there? So I want to do both of those things with the goal of making like a swimming fish or a weird goofy tentacle thing. Really the goal of like showing you how these things work, and then you making something that's creative and colorful and exciting and lifelike and crazy and weird or beautiful or whatever. So let's get started. So this video I'm going to do forward kinematics. And then I'll do some other videos that I'm not sure yet. So let me move over here and let's discuss what the core stuff that we need to build into our code is. So the idea is, and if I just think of it as two segments, that I need to have these, I think I'm going to call these segment objects. So I'm going to have segment objects that almost as if they're connected with a joint. Now, by the way, you could probably do a lot of this using a physics engine like Box2D and a Revolute joint, which I have other videos about. But I'm going to do this without a physics engine, just kind of with the raw trigonometry math that we need. So the idea here is that I have a segment, and every segment would have a kind of starting point A. We'll call this point A, which is an XY point. It also has an end point, which I'll call B, which is also an XY. And one of the crucial pieces of data that I'm going to need is this angle. So first, all I want to do is create one segment with an angle, change an angle and a length. Sorry, the distance between these 2 points is the arm's length, the segment's length. So I want to just create one segment with an A and B points and an angle, and I want to be able to turn it. Let's just do that to start. So to do that, I'm going to get out of this example here. I'm going to create a new tab, and I'm going to call it segment. I could probably think of something better, but segment, I think, is a good, and actually that's probably from Keith Peters' example. I'm sure that nomenclature is used there. So I'm going to make a segment class, and what did I say each segment needs? It needs a start point, an A. I'm going to use a P vector object to store an X and Y for that point. It needs a B. I'm going to use, that's its endpoint. It needs a length, which is the distance between those 2 points, and it needs a angle, which is the angle. Now here's the thing. Now what I'm realizing, if I go back to this drawing, is really the information is A, length, and angle. B is a point that I calculate based on how that angle is changing. And this relates exactly to this idea of polar and Cartesian coordinates. And I just made a separate video about that. What polar and Cartesian coordinates are, you can find the link to that video in this video's description. But the short version of that is, if I have a point here, and I have an angle, and I have a distance, a length, a radius from here to here, I can get this point by saying r cosine of theta, r times cosine of theta, and r times sine of theta will give me the how far to move along the x-axis and how far to move along the y-axis to get to here. So those formulas I derive and explain them more in a separate video that you could look at. Okay, so if I come over here, what I'm going to do now is say, okay, when I create the segment, what does it need? Well, it can get an X and a Y, like where is it? And it can get a length. And so I'm using just different variable names for the parameters that get passed in. And it can get an initial angle. So what I'm going to do now is I'm going to say A equals a new p vector at x, y. Length equals whatever length we specify. And the angle equals whatever angle we specify. That's pretty good. And then what I can do next is let me just write a function called show, where I'm going to draw it as I'm going to say stroke 255, stroke weight 2 or 4, and then I'm going to say line from a dot x, a dot y to b dot x, b dot y. Okay, so now the idea here is that I can say something like segment, seg for segment. Segment is a new segment, and maybe I'll have it start on the left-hand side of the screen and point to the right. So it's going to be at something like 10, 200 with a length of 50 and an angle of 0. And then I want to say segment.show. So now I have this idea of a segment. It starts at, you know, if this is my canvas, it starts right here at like 10, 200. It has an angle of 0 and a length of, I don't remember, I said 100. So I should see something like this on the screen. Now I've missed a key step here. I missed it on purpose. But let's just see what happens. Is that a background? Now let's run this. Okay, I got an error. I got a null pointer exception. So what does null pointer exception mean, by the way? Null pointer exception means you're trying to use something whose value is actually null. And so you can't use it. The value is null, nothing. Sadness, void, sad, nullness. Let's get it out of being null. And the thing that's null is not A. A is a vector. B was never calculated. So like I said, B is a thing that you calculate based on where A is, what the angle is, and what that length is. So I'm going to write a function. I think I'm going to write a function called calculate, I don't know, there's probably a better name for this. Calculate B. Update N, something like that. So I'm going to do that. Calculate B. And so how do I do this? Now I could do that math. All I need to do is say, hey, dx, the change in x, is the length times cosine of the angle. And the change in y is the length times sine of the angle. And then b is a new p vector, which is x plus dx, y plus dy. So I now have, a dot x, a dot y. So I now just calculate what is the change along x and y from A based on the length and the angle, and then give me that new p vector. And if I say now in setup, in the constructor, calculate B, we now see, there it is. There's that segment with an angle of 0. Now let's see if this is really working. Let's change the angle to, and I need to work with a unit of measurement called radians. So if I just want it to be 45 degrees or negative 45 degrees converted to radians, that you can see, now it's pointing upward. So we got the idea, this is working. I have one segment. Yay! Now, okay, so what's the next step here? Woo, I need a break. I'm going to keep going. Okay, what's the next step here? There's a few different things. One is maybe we should make that angle change. So I'm going to write a function called, I'm going to say in draw, I'm going to say, let's leave that till later actually. I was thinking like we would use Perlin noise to make the angle change or just have it turn around, that type of thing. But I do kind of want to move it a little bit over and maybe make it a little bit longer. So let's do that. Okay, so now what I need to do is I need another segment. I need another segment that connects to that segment. I think about this. Do I want to introduce, I'm probably going to need an array, but I also need the segments to have an awareness of which one they're connected to. So actually, first, let's add something. The segments are going to need to know who they're connected to, and I'm going to call that a parent. So this particular segment, oh, I got a great idea. This particular segment that I made has no parent. The parent is null. But I'm going to make a new segment that's connected to this one. Like I want to say segment 2, I really want an array, but I'm going to do it this way just for a second. I'm going to say segment 2 is a new segment, and I'm not going to give it a position. I'm just going to give it a parent. Right? I want to be able to say, I sometimes want to make a segment at this exact location, but I sometimes just want to make a segment that's connected to another segment. So I have two different ways of making a segment. And guess what? In Java, which processing is, you can have two different constructors, and you could just write both of them. So this second constructor is going to be just like the first one, but instead of taking an x, y, a length, and an angle, it's going to take another segment. I'm going to call that a parent, and a length and an angle. So its A position is actually, so first of all, its parent is not null. Its parent is equal to its actual parent, right? The one that was assigned. And its location, where it is what? This segment's location A is at the exact location where this segment's location B is. So all I need to do is say its location A should be at parent.b.x, parent.b.y. Okay, so that's another way. And then the rest is the same. Length, angle, calculate B. Okay, so this I think is good. And now I'm going to say segment 2 show. Hey, look at that. And its angle is also 45. Well, let's give it a different angle just so we can see. Let's give it an angle of 0. We can see there's our two segments. Now here's the thing. I haven't really connected these things. Like, one of the things I want to do is I would like the, what if I just wanted them to spin? So what if I put them in the center? And so that should be in the center. And I'm just going to say, I'm going to write a function called like update, where I say angle equals angle plus 0.01, just so it rotates kind of slowly. And I'm going to say segment 1 update. Is that too slow? Oh, so one of the things is it's doing it, the angle's changing, but guess what? Whenever the angle changes, I need to recalculate the endpoint. I don't see anything because I haven't calculated B. So anytime I change the angle, I need to recalculate its endpoint. So the angle changes, recalculate its endpoint. Now let's run this again. There we go. But that other one is not moving. It's not connected to it. That's no good, right? I need to say that basically, like, if I have a parent, when I update myself, if I have a parent, or if parent is not equal to null, then what I want to do is, then what I want to do, if parent is not equal to null, sorry, I'm like thinking about this, what I want to do is get my angle, well, okay, a couple things. First, I need to set A. My point A is equal to parent.b.copy. So that's, by the way, another way. I did this here. I just made a new vector from parent.b. So another way I could do this, actually, that's a little bit less code to write, is I could say parent.b.copy, which just makes copy is a function that's part of the p vector object that copies it. So I could always update by saying that. And then I can now I need to update both of these. So now we can see that they are both, that is connected. So as one turns, the other one is connected. So this is really forward kinematics. Yeah, I could do, someone in the chat is saying I could say child, not parent, and that's actually a very good point. But you know, I just thought of it that way, probably because somebody else implemented it that way. So that might be a good improvement. Maybe I'll double back and kind of see if that's a good refactoring. But I encourage you to try that as your own exercise to use to create a child rather than a parent. And so now what I should be able to do, by the way, is because when I iterate over them, I guess I could start at the last one. But if I had child, I could iterate forward through them. So now you caught me, but I'm going to keep going with the way that I'm thinking about it, and let's see if I have some time at the end, I'll refactor it. Okay, I'm actually going to keep the parent thing, but I think this idea of having child references versus parent references is something that is worthwhile considering. Here's the thing though, I just realized this is kind of working in a way that it's supposed to by accident. And so one thing I want to do is I want to segment out this idea of the angle changing from it updating based on its parent. So I'm going to just do, I'm going to write another function. I'm going to call it like wiggle or something, or I don't know, like, yeah, let's just call it wiggle, because eventually I'm going to have the arms wiggling maybe. And so that's where the angle changes. And then I'm going to call update separately. So, because I want to show you what's really going on here. Because what happens if I only wiggle segment 1? And it's not wiggling, it's turning. You can see that it's actually, that segment is always keeping, it's not moving along with it realistically. It's always keeping its original angle pointing to the right. So one of the things when you update in forward kinematics, as I'm moving forward from arm to arm, from segment to segment to segment, I always need to bring the parent's angle along with me, or pass the angle from the parent to the child. So that happened accidentally because I was rotating both of them equally, but once they're rotating in different ways, that won't work anymore. So what I want to do here, in addition to update just pulling in the parent's location, I also want to take my angle and offset it by the parent's angle. Is that enough? Is that all I want to do? Let's take a look at that. No. Oh, that's kind of interesting though. So this is way off, as you can see, because I'm accumulating all the time. I want to pass off the parent's angle, but just as an offset to whatever its own angle is actually doing. So in a way, I kind of need two variables here, which is I need it to do its own thing and then always just add. So I need to calculate its own angle based on something that it's doing, which ironically, I think if I, and then add, so if I just said angle equal, if I just start with angle equals 0 and then add the parent's angle, oh, I think the issue is actually that I do need two. The issue is actually that I'm going, this rotating the arm thing is sort of not that necessary because I'm going to calculate things in a different way. But I do need two variables, self angle and parent angle. Yeah. So what I need is, Okay. I need its actual angle. And then I think what I'm going to do is I'm going to say self angle. I'm going to create a variable called self angle. That's a good suggestion. Self angle. And I'm sure there's an easier, there's probably a condensed way of writing it, but just the way that I've created this example, I'm going to have self angle start at that same angle. And then angle is always, self angle is the thing that I might have some algorithm to change it. And the angle itself is always, what I'm going to do is angle equals self angle, right? Everything that's updating takes its own current angle as itself and then adds on, there we go, adds on the parent's angle. I think this is going to work. There we go. So the angle is 0, and this is exactly what I want. It's 0 relative to whatever its parent is. And now if I actually gave it, instead of, also negative 45 degrees, we can see now it's moving this way. There we go. This is what I want. So this angle turns, the parent angle turns, and the other angle updates whatever its own angle is relative to the parent. So they can each have independent calculations for calculating their own angle. So now, I can start to do some interesting stuff here. So for example, I can say segment 2.wiggle. And that one is going to rotate itself along, so it's rotating relative to the other one. Now, I don't really necessarily have something that interesting here. They're both just rotating, and this is weirdly very similar to my solar system example, where one thing's rotating around one thing and another thing's rotating on another thing. But I think we're going to get something much more interesting if we use a sine wave to rotate them or Perlin noise. Let's try using Perlin noise. So I'm going to add a variable called x offset, which is just going to be some random value. And I encourage you to go back and look at some of my Perlin noise tutorials. If Perlin noise is a smooth randomness. And then in wiggle, I'm going to say self angle equals the noise function. I'm going to map noise of x offset, which has a range between 0 and 1 to like between -1 and 1. And those are some arbitrary angles in radians. And then I'm going to increase x offset over time. So now, okay, so that's too fast. But we can see here, now I have this kind of arbitrary moving, almost like wiggling tentacle-like thing. So now I have this wiggling tentacle, and I'm kind of mostly done with this idea of forward kinematics, but I want to improve on this a little bit. So at very least, this is not a very sustainable path. So what I want to do is either create an array or some other mechanism. And actually, I think I'm going to try doing this without an array. So I'm going to use kind of a concept called a linked list, where every object is just linked to another object, and I can iterate through them that way. So I'm going to create something called tentacle. I'm going to make my variable called tentacle. And tentacle is a new segment. Tentacle is a new segment that starts at 300, 200 with a length of 100 and radians of -45. So now, what I'm going to do is I'm going to say for int I equals 0, I is less than 2. I'm just going to add 2 segments to it. Segment next. Okay, so hold on. What do I want? I want to say something like, hold on. I want to say something like segment current equals tentacle. Okay? Then segment next equals a new segment whose parent is the current one. And then the same thing, length 100, let's just do angle 0. And we're going to start this with an angle of 0 too. There's no reason to have that anymore. Okay, so the next segment is a new segment attached to the current segment. Current being the tentacle, which is kind of like the root. And I could call this root if we're thinking about a tree. And then I can say current equals next. So what this will do is say, I have a segment, attach the new one to that. Then make that the current segment so the new one attaches to that. So I think this algorithm should work, and I should be able to just say, now I could just say tentacle wiggle, tentacle update, tentacle show. What this should do is if I run this, it's working, but I'm only seeing that root one, the root segment. I don't see the one that's attached to it. So what I can do now is I can say segment current, I can use the same thing, equals, I'm just going to call it next actually, because just for this loop, I can say segment next equals tentacle, while next is not equal to null. Then I can wiggle, update, and show it. And then I can say, I can wiggle, update, and show it. And then I can say next equals next dot, oh wait, I have to go backwards. This is why people were telling me to use child. So how can I, so let's add child. I'm going to have both. Let's add, and you probably don't need both, but I'm going to add a child reference as well. So this is like is that called double linked list, where they're linked forward and backwards? So what I'm going to do here is when I'm creating them, next is the new segment, and then current.child equals next. So I'm also going to link it that way. And that way now, as I iterate through them, I could say next equals next dot child. So I did this in a little bit awkward way, maybe. So in other words, okay, this is hard to keep in your head, but let me try to say it again. I'm starting with, and actually, it might make sense if I diagram this, but I'm starting with the root segment, the first one. I make a new one that's attached to it, and its parent gets that current one. And the current one's child is the next one. So they're both linked to each other. And then current becomes this, so that when I link the new one, I link them with the same parent-child relationship. So that, I think, should work. And now I can iterate them. I start with the root, and I wiggle and update, and wiggle and update, going from iterating through. And eventually, one of them will not have a child, right? Because next it will be null. So I should say just here, by default, it's null. Because at some point, we'll get to the end. At some point in this loop, we'll get to the end, and then it won't come back in. So the last one won't have that child. So as long as it's null, okay, so this should work. Yeah, there's all three of them. Okay, all three of them wiggling with their weird Perlin noise thing. So let's make this a little bit more interesting. Let me think about, I kind of want it to feel more like a tentacle from the bottom. So I'm going to give its initial location width divided by 2 and the height. So at least it's kind of starting from the bottom there. But now I need to think about how that range of angle. So the range of angle should actually be between around negative 90 degrees, right? Because that's pointing up. So I want to offset that. So what I'm mapping to is like, the max angle is something like negative pi divided by 2 plus, 1. And the min angle is negative pi divided by 2 minus 1. So I want to map the noise to max angle, min angle. I have a feeling like a sine wave might actually work better than this. And now we can see, we can see what it's doing. Now, it's got a pretty broad set of possibilities in terms of its angle. So let's make this like quite a bit smaller. Oh, wait, why does it? What did I do wrong here? Oh, because, I don't want them, I only want the first one pointing up. The rest are all relative to the ones below. Aha. I don't know why I decided I had to do this like kinematics thing. So let's actually leave it at 0.1, negative 0.1, and I'm just going to do something kind of like hacky, which is to say, if it doesn't have a parent, if it doesn't have a parent, I just want it to point up because I want the whole thing to point up. I'm going to say angle plus equals negative pi divided by 2. All right. So that should, so that just has the first one pointing up, but the rest pointing to the left and the right. Okay, so that was a quick little fix. And now I can make this much, much bigger of a range. And the other thing that I really wanted to do here is I can make a lot more of these. So let's make 20 of them, and let's just make the segments like 10 pixels long. And so now we have this wiggling tentacle-like thing with Perlin noise. I don't know what it's going to do. I kind of want the range to be bigger. This is the kind of thing that it can play with forever. So let's make the range bigger, and let's maybe have the offset. Oh, you know what would be interesting to do here? I have a weird idea, which is to have the offset move a little faster. Yeah, so we can see this. Now, I don't know what this is, this crazy, creepy arm. Why is the first one? Did I make the first one is still have 100? So let's make this one 10. Right. So we can see here's my crazy, creepy tentacle arm thing that I don't know what it's trying to do. But there you go. That's forward kinematics. Let's change it to a sine wave just to see what we get. So instead of using Perlin noise, I'm going to map sine between max angle and min angle. Let's try that. Whoa, okay. And that's like way too much. So let's give that much smaller angle. So we can see now, and they're all starting. So actually what I want, I'm getting ridiculous here, but let's all start them with this. Yeah. So this actually, if I give them a perfect sine wave, it's just going to curl onto itself. But if those sine waves are slightly offset from each other, I'm off the rails here. The train has derailed for sure. But let's make this a little bit more interesting. What I really want to do is add this as a parameter to the segments. So I don't want to just have them all be 0 or all be random. Let me show you what I mean. I want that x offset, which I'm using essentially, I think in the Coding Math YouTube channel, I know that he used a variable called phase, which is kind of what, I don't know if that's right though, but it's the thing that you're passing into sine or cosine. I often think of it as time. So let me use t for time, and I'm going to add another argument here, and I'm going to set t, I'm going to do this, t equals t, and I could really improve the way that these constructors are I could combine the constructors probably in a better way. But so let me just add the last argument here, where now each of the segment always gets its time, the thing that you're passing into sine or noise or whatever to set the angle. And what I'm going to do is just pass in 0 here. Let's pass in 0 for all of them, and we should have the same exact thing. Except for I want to call this t now, and t moves up by a certain amount. Okay, so now you can see this is what happens when I have the sine wave. There we go. People in the chat are asking, what's his goal? I have no idea. This is, by the way, a way to think about creative coding. This is stream of consciousness, improvisational. I don't know where I'm going. I'm just playing around. And I really should stop soon, though. So, okay, because I'm kind of off in the weeds here. But I think there's an interesting aspect here that I could do. So now everything starts at 0. But what if the phase, we can use the word phase here maybe, or I can just say t actually, t equals 0. T goes here, and then in this loop, I say t plus equals 0.1. So what if they're all just slightly off phase from each other? Now you can see I'm getting a sort of more, a bit of a different kind of quality to this. Now it's very much of an exact repeating pattern. So I think if I also changed, not only the period of these oscillations, but the not only offset the where they are in terms of their oscillation, but change their period, which is or frequency. So that's this variable here. Okay, I'm gonna stop now, and I'm gonna let you guys play with these ideas. But I have a suspicion that if you mess around, oh, you know what? Look what I did. Sine has a range. I was using the range of output from the noise function, which is absolutely not correct. The sine function has a range between -1 and 1. So that's why, by the way, it was going. I think I'm getting close to this swimming fish kind of quality too, as well. So I kind of want to put the Berlin noise back in also, now that I have this idea of them being slightly offset from each other. So let's put noise. And we can see I kind of got this, also this wiggling quality to it, and I kind of want to make the range a bit wider to see what the sort of possibilities are. So you can see, I think that you will probably come up with a more creative way to make use of this forward kinematics idea. And it'd be really interesting to now put an array of all of these across the bottom, or map them to the. Oh, this would be great. You can make a creature, like a circular creature that has all these tentacles attached to the edges of it, and it kind of wiggles along like a centipede. Try to make Nuno in the chat is saying try to make the segments go shorter as they reach the tip, and that's certainly an interesting idea. Let's try adding that really quickly. So right now the segments are all. So I could do something like float length equals 50. And start with that here. And then I could also shrink the length. So I could say like length equals itself times 0.9. So they're like 10% shorter each time. Okay, let's make them half as long each time. So you can let's make them 75% as long each time. So, I'm not making it obvious to see how that is because I'm not drawing. I could make them different colors, but you can see there's a lot of variables you could play with here. So I hope that you enjoyed this forward kinematics coding challenge. And in the next video, what I'm gonna do is do the reverse of this, where I actually am starting where I want the end to be and how does the rest of it behave. Okay, thanks for watching and see you in a future video.